Welcome to the Day 3 material for Integrated Math 2. Today we're going to be looking at how to solve equations that either are considered multi-step equations, where we would combine like terms and then solve, or the distribute and solve variety. And then we're also going to look at how to solve equations that have exponents in them. Just as a quick review here, talking about inverse operations, obviously if I have addition, I would say subtraction would be its inverse. For subtraction, obviously addition. For multiplication, to undo multiplication, we would divide. And to undo division, we would multiply. So that should be a review. It's definitely meant to be. It's not meant to teach you those are the inverse operations. Hopefully we know that already. So the biggest thing that I can say, like I said, there's kind of a couple different aspects to really how to do this, and there's a couple different things you might be faced with. But the main idea is that you want to get it down to you want to get your equation to look like, some number times a variable. I'll use x for lack of creativity, plus or minus some other number equals some number. That's what I want to turn everything I have into. Or even simpler, if I don't have this plus or minus on here, and that means that I either have, something like 2x plus 5 or 2x minus 5, or all these numbers don't have to be the same, but this is the form that I want to simplify it to. So on this first one, I noticed that on the same side I have a negative 14 and a positive 4 that don't have variables, okay? And those are that idea is considered to be combining like terms. So when I have the 2x, and then I'm just gonna, the way I think of this is I have these two objects, this negative 14 and this positive 4, and I'm just gonna, kind of smush them together. That's the way I think of it. And what do I get when I do that? Okay, of course you can think, what is negative 14 plus 4? But some students have a hard time with that. Hopefully we understand that we get negative 10 now, or in this case minus 10. And we've made it to our goal. Like, we have number times variable plus or minus a number equals a number. 2x minus 10 equals 10, okay? So let's see what happens if I solve this equation. 2x is going to stay. I'll add 10 to both sides. So I get 20. When I divide by 2, x is going to be 10. Okay, and we can always go back and check. If I have a 10 in here for x, and then I follow my order of operations, 2 times 10 is 20, minus 14 is 6, and then 6 plus 4 is 10, so we're good. Okay. On the next one here, I have like terms in the 2j and the minus 4j. That's going to simplify to give me negative 2j. I guess I'm on a 10 kick here. Plus 10 equals 12. And when I subtract 10 from both sides, I get negative 2j equals 2. When I divide, remember I have to divide by negative 2. And 2 divided by negative 2 is going to be negative 1. Okay. And I can think of that same thing. Negative 1 in for j. So that's minus 2. Negative 1 in for j here. I've got negative 4 times negative 1, which turns into a plus 4. And negative 2 plus 4 is 2, plus 10 is 12. Okay, so that works. On this next one, I've got a little bit of work to do because I'm dealing with fractions. So we're going to review your fraction work a little bit. But I notice that I have two sets of like terms, I should say. Okay, I've got the x's and I've got the numbers, all on the same side of the equal sign. So notice I work on one side of the equal sign and then work with my solving equations. And the easiest way that I can say to do this, find common denominators or know some of your math facts. Common denominator wise, this is going to be 2/4. And notice I don't have to find a common denominator for all of it, just for the ones that I'm adding or subtracting. And this is going to be 6/10. So now I've got 2/4 minus 1/4, that's 1/4. And then I've got 6/10 minus 1/10, and that's going to be plus 5/10. You could write that as 1/2, but that's not going to be helpful for us. Just kind of foreshadowing and looking ahead. I know that I'm going to have to subtract that 5/10 from both sides, and this is already in tenths, so I'm going to leave my answer as 5/10 right there. I'll leave the 1/4 x. And sometimes, sorry, I'm not going to leave it as 1/4 x. Sometimes you might see it. I want to get us used to this idea. You might see this as x over 4. That's the same thing. Think about it. If I know what x is and I multiply it by 1/4, that's the same thing as knowing what x is and dividing it by 4. But when I subtract 5/10 to the other side, I get 2/10. And then I just need to multiply by 4 on both sides. It might be easier to see this one instead of 2/10. It's not necessary. You can do your simplification afterwards. You can see this as 1/5. 2/10, they're both even. Divide them by 2 and you get 1/5. But it makes our life easier here. X is going to be 4/5. Notice if I wouldn't have reduced that, I would have got 8/10, which is still 4/5. Okay. The next set of problems, there's some parentheses involved. But my goal is to do the same thing. I want to get number, variable, plus or minus number equals number. I've got the equals number part on each one of these. So I've got, this -135, -119, and 116. So in trying to accomplish that, I'm going to distribute first. And, maybe you're of the mindset of, well, you could add 4 to both sides. Yeah, you could. I'm not going to. I want to see that we can do the distributive property also. And typically, students jump right to distributive property anytime they see parentheses. 8 times 7 is 56. Equals 116. And now it looks like a problem that I just did above. Notice my strategy on those ones was turn it into a 2-step equation, and then a 1-step equation, and then solve. That's all we're doing here. I've got this -4 and this positive 56. So that's going to give me 8m plus 52 equals 116. Okay. So I'll take 116, subtract 52, gives me 64. So 8m will be 64. And when I divide both sides by 8, 64 divided by 8 is 8. Do the same thing on the next problem. I'll distribute first. -135 is going to be equal to -4 times 4 is -16. -4 times 4 is -16. This one has a variable on it. -7. I have these like terms here, and that's going to give me negative 135 equals, let's put the like terms at the end. Let's go negative 16p minus 23. Notice I'm just, some people will get confused because in solving you usually do the opposite of whatever it says. In this case, I've got, I'm working on the same side, so I just combine those, I add those. Negative 16 plus negative 7 is negative 23. So I'm going to take my negative 135 and I'm going to add 23. And I get negative 112 equals negative 16p. And that means that p equals, I'm actually not sure. So I'll go ahead and divide that. And divide it by 16, negative 16. And I get 7. Go ahead and pause the video and do the next problem. Alright, so getting that done, you should have distributed first, got negative 28n minus 7. Add 7 to both sides, divide by negative 28, and get n equals 4. Okay. And looking at the next page today, we look here, and basically we're just going to be solving, this is kind of our key right here. We're going to be solving when we have ax squared plus c equals 0. And in fact, when we have, it could equal anything, it doesn't have to equal 0, but this was kind of referencing a different order of this class. I kind of tailored it just for us, though. The steps remain the same. I want to get the x squared term by itself, so I want just x squared equals something. To get rid of the squared, I want to take the square root of both sides, and then and write the answer. All these are going to be in decimal form. There is another way that you could answer these, but regardless, I want to treat this variable squared as its own variable, and I just want to get that by itself. In this first one, it just means add 1 to both sides. Okay, and then I'll be left with b squared. I guess we can do that. Equals 35 plus 1 is 36. When I take the square root of both sides, the square root of any variable squared is just the variable. And then we have to know what the square root of 36 is, and that just means what two numbers multiply what number multiplied by itself gives me 36, and that would be 6. Okay. Some answers will say you need this to be a plus or minus 6, but I'm not gonna require that. But just know that sometimes that might be the case, because negative 6 times negative 6 also equals 36. Okay. On the next one, I know that I want to get x squared by itself, and to do that, I'll divide by 81. And I'm going to leave this one as a fraction for a very good reason. I noticed that 49 and 81 are both perfect squares, and when I take the square root of a fraction, it's the same thing as taking the square root of the top. So it's the same thing as saying square root of 49 divided by the square root of 81. And each one of these sides is x over here. And when I figure that out, square root of 49 is 7. And square root of 81 is 9. And again, you can give the plus or minus if you want to be complete with this. It depends on teacher preference. Okay, next one, I'll subtract 7 on both sides. And negative 91 minus 7 is going to be negative 98. And I want to divide by negative 2. So this is all I'm getting p squared by itself. So let's take 98 negative and divide it by 2. Well, I should have divided by negative 2, but hopefully you saw you get 49. So when I take the square root of both sides, that side we get p, 49 we've talked about, we get 7. Okay. Go ahead and pause the video and try the next 3 problems. Okay, hopefully you got those done, and maybe you found some weird things that happened. On the first one, I get 27, and taking the square root of that. The square root of 27, it's going to be a decimal. It's not a perfect square, so we can go around that to about 5.2. So 5.2 would be our answer there. On the next one, I get the square root of negative 92.5. Negative. And notice, I mean, even my computer freaked out at me, but it gives me an invalid input. And think about that. What two numbers could multiply, what number by itself could we square, multiply it by itself, and get a negative value? Anytime we get a negative here, we're going to say there's no solution. And it's not even, we shouldn't even say v equals no solution, just say no solution. So anytime we try to take the square root of a negative, this right here should tell us right away. Or the calculator tells us too. It tells us there's something wrong. Mine says invalid input. I know a lot will say like domain error. Anytime you get one of those errors that's not like an overflow error, that really means there's no solution. On the last one, when I add 10 to both sides, I get 0 on the right. When I divide by 3, I still get 0. And what number multiplied by itself gives me 0? 0. So those 3 were a little bit different, and you'll see some of that as we progress through. All right, that being said, go ahead and give the practice and application a shot, and stay tuned on the channel for an application walkthrough. Have fun. We'll see you in class.